All right, ladies and gentlemen, in this video we are going to look at the volume of cylinders, in this video. But before we do so, all right, what I want to do is I want to compare, a rectangular prism with a cylinder just for a sec. Consider a cylinder that has a height of h and a base radius. Of course, the circle has a base of a circle, right? Or the cylinder has a base of a circle. And a rectangular prism with the same height h, right? The same height h. And it has a square base, and those square bases are r times root pi. And the question that I want to pose is, are these two going to have the same exact volume? One's a rectangular prism and one's a cylinder. So think about that right now. I challenge you, pause the video and think about if these are going to have the same volume. So, what do we know? Well, let's think about this in terms of area. If my area of this base right through here would be r root pi times r root pi. R times r is r squared. Root pi is just going to simply be times pi. I'm going to put pi over here. Right? So that would be the area of that base. What about on the other side of things? What if I think about the area of the cylinder's base? Well, the area of a circle is pi r squared. So both of these bases have the exact same area, but one's a circle and one is a square. Are they going to have the same volume? That's the big question. Well, what do you think? Remember Mr. Bonaventura Cavalieri? Cavalieri's principle said that if the cross-section has the same area, then it will have the same volume, given that the height is the same as well, too. The cylinder and the prism will, in fact, have the same area of these cross-sections right through here, at every level of the height. So, Cavalieri would prove that the prism and the cylinder have the same exact volume. I thought that was kind of cool to show the relationship and how we can use Cavalieri's principle in some application. So what is the volume of a cylinder? Well, keep in mind, the volume of a prism was big B times H. So is a cylinder. But what is big B now? Big B, the area of the base, is now going to be the area of a circle, pi r squared. So it's the area of a circle times the height of the entire cylinder. So let's take a look here at an example. The volume, we know the volume is equal to big B times H. Because it's a cylinder, it's pi r squared times H. So the volume will equal pi times the radius squared times the height of the cylinder, which will give us that volume will be 81 times 6 pi. Now, in the end, 81 times 6 is 486, so 486 pi. Now I'm going to go ahead and just leave it like that as feet cubed for this one, just because it's exact. Keeping pi in there keeps it exact as well too. So let's maybe try another one with a little bit different, uniqueness to it, being that it's slanted. But if you remember correctly, if I made a cross section through here, Cavalieri's principle says that if it's the same thing all the way on up, it doesn't matter if it's straight up and down or if it's slanted. So for part B, the volume is still big B times H. The volume is going to be pi r squared for 4 squared times the height of 7. So the volume is going to be 16 times 7 pi for 112 pi centimeters cubed. And again, I'm just going to leave it as pi in terms of pi because that's exact of what it's going to be, and it didn't tell me otherwise in these two particular examples.